finish up activity 2. We want to mark the GPM as it flows throughout the building. So how much water will actually flow through each pipe? Okay, so that's kind of critical, and you can imagine if all the water was flowing at once, our pressure might drop a little bit in our system, and so we'd want to know the effect of that, and that's all about knowing the size of the pipe and how much water is flowing through it. So this will all tie together into our pipe sizing next week. So we're going to mark the GPM, and we call them fixture units. Okay, and in fixture units. So in each pipe segment, figure out how much water was flowing, and then we'll use text to do this. And here's our hint: we're going to work from an end back toward the trunk. So let me just, as an example, using mine, I'll do this one first, moving back toward the trunk. And so I know that this is a drinking fountain, and I found over here that a drinking fountain, somewhere in here, a drinking fountain says that it's 0.5. A water cooler, there it is 0.5. Drinking fountain, 0.5. So this is how I use this, and I could have gotten it right from over here if I was getting it too. And so I just put a piece of text in saying that this segment of pipe, from where it branches off to go to the bathrooms to here, there's going to be 0.5 flowing in this pipe to feed this. And so I go at the end. Now, let's take a look at this pipe. Again, I'm going to go from the outside down toward the main part, the main branch. So this lavatory, 1.0. So from here until it hits the toilet, from the toilet out to here, there's going to be 1.0 if everything is running. Okay. Now, in this part, I'm going to zoom in. When the pipe, when the water is flowing in this pipe and then it decides to make a turn and go out through here, this little segment right here, right after it makes the turn and before it hooks into the toilet, is going to have all the water for the toilet and the sink. So this little part right here has to add both of those together. So that's 1.0 for the sink, 2.5 for the toilet. I'm going to change this. 1.0 plus 2.5 equals 3.5. So this little segment right here has 3.5. And then, of course, it's the same going the other way. Here I'm a new piece of water, and I turn this corner, and I have to be enough to feed right here. I need to be able to feed both the toilet and the sink if they're both running at the same time. So I need 3.5 in this segment. Once I get out to here, the toilet's already taken care of. I only need 1 out here. So now I can figure out how much water I need in this one. It's everything that's after it. So in this one, I'm going to have 0.5 from here plus all of these things. And I have to consider that they're all turning on at once. And that can happen. And I'll tell you a little story about that in a moment. So that one is, right, 3.5 plus 3.5 plus 0.5. What's 3.5 plus 3.5 plus 0.5? 7, that's 8, right? 8 fixture units. 3.5, no, it's 7.5, sorry. That's not working. 7.5 fixture units. That's all of these things added up that are downstream. Okay, or it's everything that's attached directly to this node. If you do electronics, this is essentially Kirchhoff's law for current, right? That's what this is in essence. Okay, so everything that feeds into this, feeds out of this point, has to be fed by what's here. So I can just add up 0.5 plus 1 plus 1 plus 2.5 plus 2.5. Or I can look at this one, this one, this one. Okay, so now, why do we consider that everything might be on all at once? Well, I'll tell you about a situation where I was called that our valves were not functioning properly. They were valves that would regulate pressure into an area, and they said no, they kept breaking. There's something wrong with our valves, and so being the R&D field service guy, I went there, and it turned out that this was a medium level penitentiary in Tennessee. And when I got there, there were guys running out in the fields with their arms stretched straight out to make sure that they were far enough apart that they couldn't touch each other, and guys on ATVs driving around after them, and guys with shotguns. And when somebody's arms got tired and his arms fell down, he would fire the shotgun over the guy's head to remind him to put his arms up. So this was this wonderful place that I went to, this penitentiary, and it turns out that they were having troubles in one of the cell blocks. So after about 2 hours of security checks, I finally got in, and they had evacuated the cell blocks. And everybody from that cell block was standing in the yard with their arms straight out from their sides in the blazing sun with guys with shotguns. And they were all staring at me. Not a very pleasant situation. And I go in there, and the guy tells me that what happens, and this is a horrible place, I'm telling you. You don't want to end up in a medium penitentiary in Tennessee. That they would all start signaling each other. They would all get up and flush all of the toilets at exactly the same time. And these are those big commercial flush valves. And they would water hammer that place so hard that the pipes and the walls would all shake. So much water would go boom all at once. And so they were kind of considering that my valve was the problem. Turns out that that's not what our valve is designed to do or to handle, but we did have one that could. So we suggested they do that. So it is possible. Now, on a lighter note, I have done valves at hotels where they tell us, between 7 and 8 in the morning, all the time, right? 80% of the toilets flush at once every day, and all the showers go on at once every day, and all the sinks are running at once every day. So you do have to design for everything being on all at once. So the goal is here in this pipe segment, know how much water can flow through it. In this pipe segment, how much water can flow through it. In this pipe segment, how much water. In this pipe segment, how much water. Okay, and just annotate it. Now, I did this little area right here. Okay, and yours will probably be somewhat similar, but you'll need to do the rest. Like, this little bit is going to be 10, then 20, then 20 plus an eye wash, probably 21 or 22, right? And on as you go. Start from the end, work back. 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 And you will do the trunk line too, so that eventually you'll know at this point where it comes in how much water gets used.